Here's our heteronuclear correlation spectrum or HETCOR spectrum of the ortho-toluic acid. This is my favorite of the 2D NMR spectrums because it tells you for each carbon signal which hydrogens are attached to it. It's pretty powerful. It can be a little confusing at first, so it'll be good for me to go through and talk with you and label it the first time. One thing that's confusing is the proton NMR and the carbon spectra, their scales are way far away from them. So here's your proton NMR on this side, and this signal here, this singlet, that's the methyl signal, and it shows up at about 2 parts per million. So you have to go all the way down across to the right to see its scale. And then these signals here are the aromatic signals. They're showing up between 7 and 8. And our carbon spectrum up here, it's the same thing. This signal, it's a small one way out there. That one is showing up at 170-ish, whereas our methyl is showing up around 20. So that's the scales are further across. And when we label a HETCOR, I want you to number the carbon signals the same as you do in the 1D NMR, and also letter the proton NMR signals the same way you do in the 1D proton NMR. So let's look back at the carbon spectrum to help us out. So the first carbon signal, 1, the most downfield one, is the carbonyl signal. And that one is at about 170. And then we have a short signal 2. It's one of these ones that have no hydrogens. And then signal 3 through 5. And then 6 is another short one. It's one of those 2. So these are 2 and 6, if you remember. And then we have the aromatics. And then we have 8 way down here. So I'm going to make sure I use those same numbers for this labeling. So I'll zoom in on my iPad here. I'm going to call this carbon signal 1. That one, if we follow it down, it goes to about 170. And then this short one, that's signal 2. That's in the aromatic region. And it's either this signal or that signal. And then we have 3 through 5. They're these ones, all in the aromatic region. Those ones have just single hydrogens. If you remember, those are these ones here, huh? And then we have 6, another short one. That's a carbon without a hydrogen, one of those 2. 7, and then finally 8. The methyl is 8 there, and that corresponds down to like 20. Okay, and then I want to label the hydrogen NMR correctly too. So here's our 1D hydrogen NMR. I made a mistake on my HETCOR. I hate when I do this, but I'm in my garage now, so I can't just quickly fix it, and I need to be done and present this lab for you guys. But I cut off on the HETCOR, I cut off the acidic hydrogen, the acid hydrogen. See how this acidic OH hydrogen shows up at about 12.614. If you look at our HETCOR, I cut it off at 10. So there, if I went down further, there should be a signal for the carboxylic acid there. The reason why I cut it off is actually, I can show you here. This hydrogen is not on a carbon, it's on an oxygen, so it doesn't have a correlation like this. So I didn't see a correlation, and when I cropped in, I just cropped around actually, I think it auto-process cropped around here. I should have zoomed out and gotten that. My bad. But that's okay. And now, so I won't have an A signal to label. My first signal I see on my HETCOR is B at about 8 parts per million. So that's what I'll put the B at, and then there's C and D. So I want to do this correctly. So I'll put the color. I'll make this signal B because A is off scale. Sadly. And then, so that's B, and B it should show up around 8, I said, right? Yeah, it's about 8 parts per million. And then this is C, and then we have D up here. And D is the methyl, around 2 parts per million, looking good. All right, so I've got all that labeled. Now I want to again label my molecule with both the carbon and the proton labels. So I'll do, say, the carbon first. So remember, for our carbon, the first signal 1, the most downfield, is a carbonyl. That's here. Signal 2 is a short one. 2 and 6 are very short in the aromatic region. So those ones are the aromatics that have no hydrogen. So I'll circle those and I'll call them X. I'll say X equals signal 2 or 6. Then 3, 4, 5, and 7, they all have hydrogens on them. Those are these ones. 1, 2, 3, 4. I'll call those Y. So Y is signal 3 or 4 or 5 or 7. And finally, signal 8's an easy one. Oh, sorry. Oh, shoot. I clicked the wrong thing on my iPad. That's what I want. Zoom in on that. Signal 8's an easy one. That's the methyl out there. Okay, so I've got all the hydrogens labeled. Now, I got all the carbons labeled. Now I want to label my hydrogen signals. So signal A is this one. That's the one that's off scale. I cut it off on accident, but that would be my A. And then B and C, we don't know what they are, but they are going to be the same Y. I'll just call them Y. Okay. So this will be B or C, because we know these ones are in the aromatic region, and those are the Ys, or the one hydrogen, all those aromatics. And then D is my methyl, so that's going to be corresponding with 8. There's my D. Okay, I got that labeled. So now let me fill in the HETCOR table, correlation table. So I just kind of came up with this table to make you think a little more about the spectra and see if it makes sense. So what it's asking is, for carbon signal 1, which this is this one here, hydrogens on that carbon, how many hydrogens are on that carbon? And I'm supposed to answer this first column with the data from the HETCOR, but I can't because I blew it. I didn't, I cut it off. Cut off. So it should be 0 hydrogens. And does it agree with structure? I can't tell. Sadly, because I made a mistake there. Okay, let's move on. Carbon signal 2, if you look at carbon signal 2, you'll notice that it doesn't have a correlation on the HETCOR. So let's follow it. So carbon signal 2, as I come down, straight down from 2, I don't hit any correlations. I don't hit any of these signals here. So that says that carbon signal 2 doesn't correlate with any of the hydrogens on the NMR spectrum, so carbon signal 2 has no hydrogens. So we'd put in the table that carbon signal 2, hydrogens on carbon, I'll type that in as none. And does that agree with our assignment of our structure? Carbon signal 2, yeah, because we said carbon signal 2 was one of these signals that had no hydrogen. So yes, looking good. Oh. Nice. Okay, what about carbon signal 3? So carbon signal 3 does have a correlation. So carbon signal 3 is the most downfield of the carbon signals in this grouping in there, 3, 4, 5. So it looks like it correlates with this one right here, huh? This is carbon 3. It's since carbon signal 3 is the most left of 3, 4, 5, the most downfield, and this correlation is the most downfield, it's got to be that one, right? So where does that correlate in the proton NMR? That means it correlates with, oh, what do I do? Got to undo that. There we go. So that correlates with signal C. So carbon signal 3 has hydrogens from signal C, not signal B. So That's something, right? Found out a little something. So let's fill in our diagram. Our table. So I've got carbon signal 3 correlates with hydrogen's C. And does that agree with our assignment? So we said 3 was one of the Y signals, and we said C was one of the Y signals. So yeah, it agrees. Looks like signal 3, carbon signal 3, corresponds with C. And does that agree with our spectra? Well, we did say 3 was one of the Y signals, and C is one of the Y signals. So yes, it looks good. Next, we'll go to 4. Carbon signal 4 is a little more downfield of 3. I'm going to guess that it's not easy to tell with this one, huh? But I'm going to say 4 is probably still hitting that same one. This looks like 2 signals to me. It looks a little bigger, more significant than that one. So I'm going to say that that is C4. And then I'm going to say C4, I think it also corresponds with the C there, huh? So I will say C4 looks to correspond with C as well. Does that agree with our predictions? So C4 is a Y, one of the Y carbons. And the hydrogens on the Y carbons are C or B. So yes, it agrees as well. Some of this is kind of obvious, but hopefully you can see with the more complicated molecule or different molecules, you'll get more information out of it. Okay, next up is 5, carbon 5. So let's look at that one. So carbon 5, that's the most upfield of that cluster of 3, 4, 5. So I need another color. I'll go red on this one. So for 5, I think 5 looks like it's going to go to that one there, huh? Because this correlation is more upfield. So, and 5 is more upfield, so it's got to be that one. So 5 corresponds with B. So we got B. And B, what did B integrate to? I think did B integrate to 2 or 1? Let's look back actually. Maybe I'm doing this wrong. Yeah, no, B integrated to 1. Good. So B integrated to 1. So one of these is the B. Yeah, and now we know it's carbon signal 5. That's the 1 hydrogen signal. That one there. Okay, so back to our table. So 5 corresponds to B, and does that agree with our prediction? So 5 is one of the Y's, B is one of the Y's. Yes, looks good. All right, and now let's go to 6. 6 is the short one, huh? And it looks to me like 6 is not corresponding to anything. So, actually, I'll label this carbon 5 as the red one. Oh, carbon 5. So 6, I'll do it in black. So 6 is just coming straight down, and it's just missing everything, huh? 6 is like 2. This is carbon 2, huh? So carbon 6 has no hydrogens on it, which we predicted, huh? Let's fill that in the table. So carbon 6, what hydrogens are on it? None. Does that agree with our predictions? It does, because we said X was 2 and 6, and they have no hydrogen, so yes. Great. And now, okay, 7. I'm going to have to use green again. I'm running out of colors. 7 hits there, huh? I'll make that look more appropriate. Boom, there's 7. And which does it look like 7 agrees with? Does it look more like it correlates with C or B from 7? Oh yeah, that's going to C, huh? So C7. It's getting a little too busy here. I guess I could do it again though, huh? There we go, it's going to C. All right, so let's put that in our table and see if that works out. C7 goes to hydrogen C. Does that agree? 7 is one of the Y's and C is one of the Y's, so yes. Looks good. And finally, 8. 8 should be an easy one. Eight comes down, it hits right here. And when you come across from that, what do we see? It corresponds to D. It corresponds to D, and does that agree with us? It sure does. We have 8 and D right back next to each other, huh, the methyl? So yes. Looking good. And so my only comment is I wish I did not cut off the not cut out the acidic hydrogen. That's okay though. So thanks for listening. Now I'll have you go back to the Google Doc and recreate what I did. When you do the Google Doc, if you want, you can leave off all these lines. They get a little busy. I just draw them the first time I explain it to you, but you can just like visually watch it with your eye and you can just fill in the table. Okay, thanks.